Hello everyone. So in this video, I'm going to talk about another math count problem. So this is a geometry problem. So let's start with this one. So we have a line bisecting the large acute angle in a triangle with the sides are given. Okay, divides opposite side into two segments. Okay, what is the length of the shorter one? Okay, so it's a triangle, but before you like kind of start drawing a figure, so look at the numbers carefully. We have 33, 44, and 55. And if you do recognize those numbers, which is really nice because this is actually our one of the best triples that we always use, 3, 4, 5. So this is like 11 times of 3, this is 11 times of 4, and this 11 times of 5. Again, if you are not familiar with the triples, so like Pythagorean triple is basically any three numbers that will satisfy a right angle triangle, okay, or Pythagorean theorem itself. So the 3, 4 is the leg, and the 5 is the hypotenuse. And then whenever you multiply these numbers by any numbers, you do get another right triangle. Okay, this is the first circle, and then we have another one, which is like 5, 12, and 13, and 8, 15, 17. Some of you like heard these from me a lot, and then if you don't really still remember these, it's kind of a shame, but please take like some notes somewhere so you can like use these whenever you need to. So as soon as I see this is like 33, 44, and 55, that means this is actually a right triangle, okay? Then I'll go with drawing a right triangle. Okay, so let's say this is my triangle. So since we have 33, so let's say this is 33 and 44 and 55, and this is 90. Again, if you don't see this immediately, so maybe you can go ahead and try using Pythagorean to check that. So you can say, okay, 33 is the smaller side, and another smaller one is 44. And if this is equal to square of the third side, which is going to be hypotenuse if it's a right triangle, yeah, if you square these and add it together, that will be actually the same as this one. But again, we don't really do these because this is a sprint problem, so which is why we don't want to do too much work, especially with our calculator. But if you do recognize this is 3, 4, 5, that's a right triangle. If you don't, then this is something you can go ahead and try, and then that will actually be equal to each other. Okay, so now we are told a line bisecting the larger acute angle. Okay, so the angle that will be acute, either this one or that one, right? And then the larger of these, the one that is actually opposite the larger side, which is 44 of these two legs. So which means we are going to have a segment which is going to divide the larger acute angle, which is this corner, because this is the angle that is opposite to this side, which is the larger leg, okay? So if I name these, let's call these ABC. And the question was asking, this segment actually divide opposite side into two segments, and we are looking for the shorter one, which is, we are looking for this guy. So if I call this is maybe H, so we are looking for BH. Okay, so at this point, we do need to remember two things, maybe actually one thing for at least this solution, is the angle bisector theorem. So if you are not familiar with the angle bisector theorem, so which is why I'm gonna kind of remind this one more time for those of you. So angle bisector theorem is a relation when you between the side and the divided pieces when you do have a angle bisector. So if you're, let's say this is A, let's say this is B, if this segment divides angle A into two equal angles, we call this an angle bisector. So whenever we have angle bisector, we have a really nice relation. The ratio of this guy, if I call this is A, to this, okay, I'm gonna call this is X. So ratio of this side, if I call this is A over X, this guy will be equal to ratio of this side to this side. So if this is B and this is Y, so that will be B over Y. Okay, and this is called angle bisector theorem. Okay, so just keep this in mind. And we are gonna use this in our case. So we are given like this is 35 and this is 55. The ratio of 33 divided by BH is equal to ratio of 55 divided by HC. So you could go ahead and write this ratio, or you can say that, this divided by this is just 3 to 5, right? That means this divided by this divided by that should be same based on the angle bisector theorem. So then I can say this guy could be 3 times something, while this guy is going to be 5 times something. So we do know this total is 44, which is actually 8x is 44. So if you divide by 4, you get 11 equals 2x. That means x is 11/2. Okay. So the x is 11/2. Well, we want to answer the question, which is we are looking for the shorter piece, which is 3x. So 3 times 11/2 is our actual answer, 33/2. Okay. So that is one way by using the angle bisector. Okay. But you could do this question maybe in a different way. Okay, but I'm gonna leave that part for you to explore it. Okay, but for now, using the angle bisector is actually okay to do so. Okay, so that's my answer.